We tend to put certain scientific discoveries on a pedestal.
Right, the perfect skeleton.
Exactly. The pristine fossil, the perfectly preserved egg. But so often, the really great knowledge, it comes from the places we almost ignore.
Mm-hmm.
What if I told you that the discovery of a brand new pterosaur species, a flying reptile from the early Cretaceous, was only possible because it was found inside fossilized vomit?
It's the ultimate paleontological trash to treasure story, really.
It really is.
Yeah.
We're diving deep into Bakuribu or Ritza, a fascinating new addition to the prehistoric world. But, okay, let's unpack this. We have to talk about the source material.
We do.
This fossil is a regurgitolite. What is that?
A regurgitolite is, it's the fossilized remains of stomach contents that an animal expelled orally, so not the stuff that goes out the other end.
And why is that so important? I mean, why do we care so much about ancient stomach contents?
Because findings like these give us the only direct insight we can possibly get into ancient food webs, into predator-prey dynamics. It's not guesswork.
Wow. Okay, so set the scene for us. Where are we?
We're in northeast Brazil, the Rimaldo Formation, which is known for just incredible preservation from the early Cretaceous.
And this pterosaur is a big deal for the area, right?
It is. This is the very first definitive filter-feeding pterosaur ever documented from the tropics. It completely changes things.
That alone shifts our understanding.
Yeah.
So tell us about the creature itself. What was Bakuribu or Ritza?
It's a campanocasmatid pterosaur.
The filter feeders.
Exactly. That's the family known for these specialized long-jawed filterers. The fossil itself is, it's pretty fragmentary. It probably represents at least 2 different individuals.
And I love that the team who found it really went out of their way to honor the location.
They did.
The name, Bakuribu and Waridza, can you break that down?
So Bakuribu is the Kariri word for comb, and Waridza means mouth. It's a tribute to the indigenous people of that region.
Comb mouth. It speaks directly to its anatomy, doesn't it?
Perfectly, like its more famous relative, Pterodastro. This thing was a filter feeder. You have to imagine these extremely elongated jaws lined with just incredibly dense, brush-like rows of teeth.
Like a sieve.
Exactly, designed to strain tiny crustaceans or larvae from the water. The estimate for the total tooth count, it's somewhere between 440 and 568 individual teeth.
I can't even imagine. Analyzing that many tiny fragmented teeth from partially digested bone, that requires some serious data modeling.
Oh, absolutely.
It makes you appreciate how complex the work is.
Mm-hmm.
And speaking of needing specialized partners for complex data analysis, AI training, or automation, that's exactly where our sponsor comes in.
Uh-huh.
If you're trying to figure out where AI agents could make the most impact for your business or even your personal life, you should check out embersilk.com for your AI needs. They handle the hard data so you can focus on the discovery. So back to our unlucky pterosaur, you mentioned it's like its relatives. Does it fill some kind of evolutionary gap?
A major one. Bakuribu is anatomically intermediate, meaning its jaw and tooth refinement sits right between the older, more generalist stenocasma and the hyper-specialized skimming you see in Pterodastro.
So it's a transitional species.
Yes. It tells us that the evolution of this kind of specialized filter feeding wasn't some overnight switch. It was a long, slow refinement of that tooth comb that happened across different continents.
Okay, but this is where the story gets really interesting for me. It was eaten.
Right.
So this ancient food waste dump tells us about the predator. How sure are we about who ate it? A spinosaurid dinosaur seems to be the main suspect.
The evidence is pretty strong. It's about the preservation pattern, what we call taphonomy.
How was preserved?
Exactly. The pterosaur fragments were all tightly clustered together right alongside 4 fossil fish. This strongly suggests they were all eaten together and then, well, thrown up as an indigestible mass.
And that points to a spinosaurid.
Given the other fossils in the Rimaldo Formation and other bite mark evidence we have from the area, yes, a spinosaurid is the prime suspect. This single find gives us a vivid snapshot of its diet.
That is just extraordinary. One discovery reveals secrets about anatomy, evolutionary paths, ancient food webs, and it even honors cultural heritage.
It really is a rich piece of science.
So what does this all mean looking forward?
I think it proves that the potential for huge progress is, well, it's everywhere. This inspires scientists to go back and scrutinize every museum specimen.
Even the weird ones.
Especially the weird ones. Even discarded material like fossilized vomit can hold the key to filling these massive evolutionary and geographic gaps. It just points us toward a more complete understanding of life on Earth.
That's a fantastic and hopeful note to end on. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out about discoveries like this. Thanks for tuning in.